Okay, let's continue with the EIGRP lab. In this case, we're going to configure the address family IPv4 for the global routing table in this device, this router, this nexus, and this nexus. So basically, what we want to do with the global routing table is advertising the loopback IP address that belong to these interfaces, because we want to be able to manage them, maybe gather statistics, connect them through secure shell, and so on. So we are going to use, in the case of the green network, these particular sub interfaces. Remember that we are using data path virtualization because we are managing also BRFs. So in the case of the VLAN 10 in the green network, this VLAN 10 has some SBIs here. This we are going to configure these SBIs as passive interfaces for EIGRP. We are going to configure EIGRP also for the address family IPv4 BRF users. We are going to use these particular sub interfaces in order to create the neighborships between devices. So we are going to configure here the BRF users, BRF users, BRF users, BRF users. Now for VLAN 100 and 101, we have a couple of SBIs here that also belong to BRF users. We are also going to configure them as passive interfaces. Now we are also going to configure the address family IPv6 for the BRF users with EIGRP. So we are going to configure that here, 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 here. That means that we have to enable IPv6 in this subinterface, this subinterface, this subinterface, this subinterface, this subinterface, this subinterface, and at VLAN 100. Now, the BRF users is aimed as corporate users, so we also have the IPv4 address family for VRF guests. So we're going to configure that here, 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 and here. And we are going to use these sub interfaces because we are using data path virtualization for our VRFs. We also have one VLAN for guests, which is 102. This VLAN has a couple of SBIs here. We are going to configure this VLAN as passive. Now, as a final tuning for this configuration, notice that, for instance, this router is going to create a neighborship with this router and with this other, with this nexus and with this other nexus. So we want to have this link as a secondary link. In order to achieve that in EIGRP, we are going to configure a higher delay. For instance, we are going to set up a delay of 1000 microseconds here, and we are going to do also that for these sub interfaces. So we want this link and this link to be the primary link for the global routing table for the VRF users and for the VRF guests. So we are going to configure these delays in order to achieve that. And as a final note, the EIGRP that we are going to configure here is going to serve as the underlay for later on configuring VXLAN and EVPN. So let's jump into the lab. And so let's go for router V1. Remember that we are going to configure router V1, router V2, Nexus 3, Nexus 4, Spine 1, Leaf 3, and Leaf 4. So let's go to router V1 and let's enable IPv6 routing and enable IPv6 in the interfaces that belong to the VRF, the user's VRF. So we are enable IPv6 routing and enabling IPv6. Remember that when we issue this command, an automatic IPv6 address is configured to the interface that is known as the um, link local IPv6 address. Now let's configure EIGRP. In this case, we're going to configure the address family for the global routing table. We are going to use always the autonomous system one. Notice that we are not assigning a router ID because we have a loopback that is going to be the interface that is going to provide the router ID for this address family. Now let's create the address family IPv4 and IPv6 for the users VRF. Now notice that we are assigning manually an IP and a router ID for each of these address families because I don't have a loopback that exists in the VRF users that is able to provide this router ID. I have a loopback that belongs to the global routing table, so I don't need to provide a router ID here. So I am using this IP address that belongs to this loopback that exists in the global routing table to provide a router ID for these address families. Now notice that I can use the command network in order to make interfaces participate in an IPv4 address family. But this command network does not exist in IPv6, so I have to enter this mode AF interface. So in this mode, I can add interfaces to EIGRP for IPv6. Now let's configure the users, the guest VRF. Okay, same deal. We are going to provide a router ID, and we can use the command network for this VRF because it is an IPv4 VRF. Now let's do the same in router B2. Okay, it's practically the same. Notice that we are using this format because we are using named EIGRP. Now let's configure Nexus 3. Remember that the configuration for Nexus is a little bit different. First, we're going to enable EIGRP. Okay, the first thing we are going to make sure, and I didn't comment for the other devices, is that your VRFs must support the correct amount of address families. So for instance, we are going to configure EIGRP for IPv4 for users, so we only have to enable the address family IPv4 within the VRF definition. But for the VRF users, for the VRF guest, for the VRF users, we are going to configure both IPv4 and IPv6. So in this case of the definition of when defining the VRF users, we have to enable the address family IPv4 and IPv6. So let's configure now EIGRP. Now notice that we can use the command network for address families that are IPv4. For IPv6, in this case, we cannot enter into the AF mode. It is not available in Nexus. So we have to go into each interface and add each interface into EIGRP for IPv6. So I am going to enable IPv6 in these interfaces that belong to the VRF users. Remember that we are using IPv6 only in the VRF users. Now we have to make VLAN 10, VLAN 100, VLAN 101, and VLAN 102 as passive interfaces. So let's configure that. Notice the command for Nexus is this one. And so we have configured Nexus 3. Let's go and do the same for Nexus 4. Okay, first we're going to make sure our BRFs are correctly configured. Address family IPv4 for guests, and IPv4 and IPv6 address families for the user's BRF. Next, we are going to configure EIGRP. And then let's add interfaces into the address family IPv6 for users. And then finally, we're going to make VLAN 10, 100, 101, and 102 passive interfaces. Okay, so far so good. Let's go and configure the data center Nexus, which is the spine 1, leaf 3, and leaf 4. Okay, let's enable the feature EIGRP. Remember that these are Nexus commands. And in this case, given in these devices, we are only going to configure EIGRP for the global routing table, only for creating an underlay for later on configuring VXLAN and EVPN. The configuration is quite simpler. We are just going to create the address family for the global routing table, and we are going to include all the necessary interfaces. We are not going to work yet with the VRFs. We are going to leave the VRFs for EVPN and VXLAN. So let's go and validate our config. Now remember that the way that you validate config is through using show commands. So router base should have 3 neighbors. In this case, let's see the neighbors that this router has. For the global routing table, we have 3 neighbors. 3 neighbors. This will be router 2, Nexus 3, and Nexus 4. And we can also test the same for the BRF users. We must have 3 neighbors. For IPv6, for users, 3 neighbors. For the guests, BRF, 3 neighbors. We can test that here as well. Show EIGRP, address family IPv4, neighbors. And in this case, we have 4 neighbors because router B2 is also being connected to the data center. So this is the neighborship with the data center, with the yellow network, and this is the 3 neighborships within the green network. Remember our topology here. Now let's see now how many neighbors we have in the user's BRF. And let's see, 3, correct. Now 3 neighbors for the BRF guest, and for IPv6 for the user's BRF, we also have 3 neighbors. Okay, let's test that here. The command in Nexus is a little bit different. So we have 3 neighbors in the global routing table. 3 neighbors for the IPv4 address family for users VRF, and 3 neighbors for the address family IPv4 for the guest VRF, and we should have 3 neighbors for the address family IPv6 for the users VRF. Okay, correct. Let's test that here. So we should have 3 neighbors in the global routing table, 3 neighbors in the BRF users, 3 neighbors in the guest BRF, and we should have 3 neighbors for the address family IPv6 for the users BRF. Okay, great. So let's go for the data center devices. Let's see, the spine should have 3 neighbors, one that goes for the green network and leaf 3 and leaf 4. So show EIGRP data center neighbors. So this is the connection between the yellow network and the green network. This is leaf 3 and this is leaf 4. Remember our topology. Now let's go for leaf 3. This should have only one neighbor. So IP EIGRP data center neighbors, which is a spine 1, and this should have only one neighbor. Show IP EIGRP DC neighbors. Only one neighbor, which is spine 1. So let's see the routing table. So this is the global routing table. Notice that I am reaching many networks through 2 interfaces. For instance, let's see, this is the prefix that belongs to this device, access B. So notice that we have 2 ways to reach access B from router B1. This link that goes from router B1 to Nexus 3, and this other link that goes from router B1 to Nexus 4. So we want to make these links, for instance, the one that goes from router B1 to Nexus 4 to be a secondary link. And we want to make this link, the one that goes from router B2 to Nexus 3, a secondary link. So we need to increase the delay. As a network administrators, we are capable to artificially increase the delay. So, and remember that EIGRP takes into account the delay for calculating its metric. So if we increase the delay in this interface and in this interface, we are going to actually make this interface lose against this interface, this interconnection, and this interconnection. So let's go and do that. Let's manually increase the delay because I don't want to see 2 paths for the same destination. I want to see only one primary path and and if this link goes down, take this other path as the backup. So let's do that. We're going to have to configure these sub interfaces that belong to 2300, 2301, 2302, and 1400, 1401, and 1402 with an increased delay. So let's go and do that here at router B1. So 1400, 1401, and 1402. And let's do the same in the Nexus 4 device. Fourteen zero zero, 1401, and 1402 with an increased delay. Let's go now for router B2. And let's modify the delay for the subinterfaces 2300, 2301, and 2302. Let's do the same for Nexus 3. So for 2300, 2301, and 2302, we're increasing the delay. Now, after doing that, if we issue show IP route, for instance, we are going to see only one path to reach this destination. Previously, we had two paths. Now we have only one path. So in this case, this link became the backup and this link becomes the active. And now we have complete routing, layer 3 routing at the data center and at the green network. So for instance, we can ping everybody to everybody. So let's go for and open this, for instance, this device here. So this device has this IP address, and its default gateway is in the BRRP virtual IP address that we have configured at Nexus 3 and 4. So, and this is used for management. So, for instance, we can ping 10.2.1.1, which is router V1. Router V1. We're working here at access B. We can ping router V2. We can ping Nexus 3. We can ping Nexus 4. And let's see why Nexus 4 is not pingable. .2.14. Oh, I think this device does not have a loopback yet. So let's configure a loopback. 10.2.14. Then it should be pingable now. Okay. We can do a trace route, for instance. And we can ping, for instance, the data center switches. Spine 1, leaf 3, and leaf 4. Even though we only have a default route. And the default gateway for this will be Nexus 3, which has a complete routing table learned by EIGRP. We also have routing table for VRF. So for instance, show IP route VRF users learned by EIGRP. We have the guest. We should also have show IPv6 route. Remember that the only VRF that has IPv6 is user, so we can see the routing table. We only have this prefix, which is the prefix that we have configured in VLAN 100 and at the SBI that belongs to VLAN 100. Remember, if we go here and we see VLAN 100, this belongs to the user's VRF, and we are using this prefix, this IPv6 prefix. So show IPv6 interface brief, VRF users. So this is the prefix that we are using for VLAN 100. This is the one that is shown here. Okay, that's it.